It is a real pleasure to welcome Dan and Bryan to the stage to talk about what I think is a very exciting innovation, very exciting work project that we're working on together. Basically, I went out to Poughkeepsie about a month or two ago. You ever been to Poughkeepsie, New York? It's an awesome place. Still back in the 70s, it feels like sometimes. I couldn't find a place to eat, actually. I went up there and I walked for about 10 minutes trying to find a place to eat. It was 9:30. I walked up to the Wendy's there and went up to I didn't have a car. Oh. And so I walked up to the drive-in because they were closed. And of course, they can't serve you in the drive-in that way. But despite that start, the next day was filled with what just blew my mind, actually, that IBM had a partner in Rocket Software that's been building software for mainframe for a long time. And they've actually been on this initiative to bring modern tools to the IBM mainframe for some time. Yep. And we talked about how with the big data stack, there was an interest from customers in bringing the tools like Apache Spark, tools like R, tools like Python, Perl to IBM, ZOS. Basically, the mainframes, anybody watch Hidden Figures? The Hidden Figures show, if you haven't seen it, you've got to go see it. It's it's probably one of the best films I've ever seen, actually, for quite some time. It's a remarkable story of some significant women who had a big deal to do with the space program. And it was a little funny because they showed the IBM machine being brought in, rolled into they couldn't fit it in the place. It was this punch card thing, nobody knew what it was. They had to program in Fortran, though. That was a high-level language, modern language, still close to my heart. SciPy was built on Fortran. But what they did is, that's a mainframe. And for many of us, that's what a mainframe is, that old clunky thing that somebody uses still, but who knows who uses that. Then I went out to Poughkeepsie, and I met these two folks and realized that there's a ton of data actually still running on mainframes, a lot of data that I want to process. I want our tools to be able to process. So I was really excited when we found out how possible it was for Anaconda to be brought to the mainframe. And Rocket had done so much work already that it was basically some coordination, some conversations, and we could make this happen because of their previous work in kind of short order. They also got some really smart folks there. And so I was really excited to see that. And so I'm excited to see kind of how far we've gone. We're really supportive of the idea. We had some conversations with our Anaconda team and their team, but the lion's share of the load has been lifted by Rocket and IBM, and we're just thrilled to help make that really a reality. Make sure Anaconda works smoothly on IBM mainframes. ZOS it's called. I didn't even know what that was. Mainframe is what I thought it was, ZOS. Yep. So Anaconda on IBM on ZOS is what we're here to announce and talk about. So Dan, yes. Tell us the story.
Yeah, so we're from IBM, and we're very excited about this partnership. Again, it's a partnership of three companies. What I'd like to basically introduce you to, as Travis pointed out, is that a lot of you data scientists have a stumbling block, and that is access to data. We all have it, right? I mean, not all the big data you think about is on the internet, and I think we're all tired of the Irish data set, right? So where's the big data? The big data really is in the big enterprises. Transactional data that is actually being collected every day, whether it's order processing, claims processing, payment processing, it all is gathered and collected on mainframes around the world. It was interesting yesterday, I was talking to Michelle earlier, it was fantastic. We have in the audience here members of enterprise companies who have mainframes. They didn't talk about it. In fact, State Farm, Capital One, General Motors, JP Morgan, and you had the United States government data science team here, right? Every one of you folks have mainframes. You may not be using the mainframe, but your data that you're using for your data science originates. The point of origin is in the mainframe in your shop. What we're here to do as three partners is to help you get access of taking that compute, that Anaconda foundational services, and bringing them over to the mainframe and getting the value of running compute co-located on the, with the data.
You're talking Dask?
Dask.
You're talking NumPy?
All of it.
SciPy? Pandas?
All of it. Jupyter Notebooks.
Jupyter Notebooks?
All of it. On-premise, on the platform.
That taxi cab data set that a lot of people might have seen. So
20 gigs?
What about TensorFlow? TensorFlow and Dask?
We can do it.
I bet we could do TensorFlow.
Yeah. It's going to be exciting.
It's actually pretty impressive.
It'll be exciting.
Really impressive, because all of a sudden you see, most of us are going to experience our computers through a web interface.
Right.
Right? That's kind of where the world's headed. We're sort of back to the future. Sun was pushing us there. IBM was pushing us there way back in the day, but the terminals were really arcane.
Yes.
Now our terminals are nice. Right?
Right.
They're a phone. They're a nice tablet. The web browser's gotten better. Jupyter Lab's going to blow people away with how nice that makes a terminal.
Yeah.
I'm super excited about that. You haven't heard much about that today, but where Jupyter's heading is amazing, and there's going to be some amazing tools. And imagine that where the data is,
Yes.
you can run it. But I thought it was expensive to run on the mainframe.
Good point. Yeah. You know what? Run COBOL, it is. You know,
Okay.
Traditionally it is. But what we're doing, we're taking first-class languages like Python and making them inexpensive to run on the mainframe, making those workloads economically efficient to run on the mainframe. So there's no reason why modern skills, modern programmers, portable skills, if you wish, in the enterprise, can't run on platform, right, and access the data where natively as its point of origin. And you know, it's all thanks to the guys at Rocket who have ported. Think about all the dependencies of all the libraries in Python and the entire Anaconda stack, the SciPy stack. Rocket guys have all ported it for us. So what I would like to do is just kind of go through a couple of things of where, you know, some of the challenges of why really focusing on the mainframe and some of the challenges our customers have thought about of using Python on the mainframe. So Bryan, you want to chat about what kind of data is actually analyzed?
I will. One point, so you know who IBM is, so Dan didn't really need to take you through the 100 years plus of what IBM has done with the mainframe. I just want to give you a quick 30-second of who Rocket is. So Rocket, private company, been around for 27 years. We've been a partner of IBM's for more than 20 years. We build a lot of products for IBM. It's a great partnership. I think it's a very unique partnership. Having been an IBMer before myself, I never saw two companies really work as well together. And this triumvirate here is going to be, I think, even better.
Yeah, one of the things I saw when I met both you and Dan out in Poughkeepsie, and I hadn't heard of SoftRocket before then. I looked it up before I went. But I was really impressed, actually, with how much Rocket has been doing. Apparently, you haven't gone away from the mainframe. You've been helping people for 20 years. You said 20, 25 years. It was impressive to see that, and especially when I saw the level of skill. Like we've been building software for a long time, and watching the people there take this stack and build it for the mainframe very, very quickly. It's a testament to the software itself. The software is cross-platform, easy to compile. There isn't a ton of work that has to be done, but it is some, you know, build work is a bit of messy.
Yes.
There's little things that have to be done, and I did the heavy lifting to make that happen. You've been doing that for a while, though, it sounds like.
We have, so we're primarily an R&D company. We have a very small portion that we do direct sales, but we're an R&D company. That's our strongest muscle. Over half of the employees, we call ourselves Rocketeers. Over half of us are engineers, and that's not very common in most software companies. So we take great pride in that, and we build up our R&D muscle every year. But this is an exciting conference for me. So first of all, I'm not a data scientist, but I've had a great time the last couple of days in talking with many of you. Like Dan was saying, you know, so many of you represent enterprises who have a mainframe, and some of you, I learned, didn't even know you had one. The mainframes are as strong today as they were in the past. There's certainly companies who want to get off the mainframe, but there are as many and even more companies who see this as an investment in their future. They are increasing their investment in the mainframe. It's not going away anytime soon. Every credit card transaction that happens involves a mainframe. Every time you get money out of an ATM machine, you're interacting with a mainframe. So there's all this data, and that's what this is trying to show. All this data is on the mainframe. You might have heard this story, you know, that there's an interviewer who asked a very infamous bank robber. He said, you know, why do you rob banks? And his answer was, do you know? That's where the money is. So why mainframes? That's where the data is. That is where the data is. And today, go to the next slide. Yeah. Today, the way that I think that most of you are consuming that and using that and mining that information is by way of an ETL process. And I've heard a lot of presentations here the last couple of days about ETL, and kind of tongue-in-cheek, at Rocket, we believe that ETL is dead. We believe that the future for ETL is very bleak. If you look back to the mid-1990s, you had this scheme where you had your online transaction processing systems, mainframe-based, right? Transactions run there. And if you want to do any type of business intelligence or analysis or reporting against that, you took that data and you copied it. You ETL'd it over into a data warehouse. But that architecture has stuck around for way too long. Its days are numbered. So what this is doing is it's taking, instead of moving the data to the analytics or moving the data to the place where you're going to be doing your work, move that application, move those analytics, move that data science experience over to the data, right? That ETL processing is very slow. And the other trend that is interesting with data warehousing was that folks said, it's okay if I'm looking at data that's a week old. I don't really care. It's okay if it's maybe a day or two old. But the trend was that they wanted to have more and more current data, to the point now that real-time data access is very important. And you can't do real-time analysis, you can't do real-time data science against data that's been copied. Not to mention the other costs you have with ETL and inconsistency and all that.
Not to mention, we do the ETL, you're adding latency into your data analytics. You're no longer real time. Furthermore, on the mainframe, you're doing that ETL workloads, that's costly. So all those folks out there who are doing data science, like we mentioned, Capital One and others, you're actually paying extra because you're moving the data off using that ETL process. Moving Anaconda onto the platform and doing your data science natively on the platform, you cost removal right there. So more economically efficient, right?
I got two small stories around this concept of this ETL process, where one is an Australian bank, and I was there last fall, and he said, Bryan, usually I would always know when I would hit my peak transactions on my systems. And in Australia, that's always December 24th. They don't have a Black Friday, no Thanksgiving, I guess. So it's on December 24th. He said, but I just had a peak back in April, and I had another peak 2 weeks ago, and I have no idea why that is. So he's trying to take tools. He happens to be using Spark, but that's only because Anaconda wasn't there, by the way. He's using Spark to
We like Spark too.
Analyze this, to understand other feeds. What's happening geopolitically? Is there a Brexit vote? Is there an Olympic event? Is there a World Cup? What's the weather like? Because he wants to be able to predict that in real time to understand what the capacity is. Another example, which is a little closer to my heart, is that we worked with a Florida law enforcement agency who, when they would pull over someone on the road in the car, they would then type in the information they have about the car, the license plate number, and they would get information up on the screen, right, just to tell them, you know, what do we know about this? Is this a bad situation? What do we know? And that process would take up to 7 minutes. And there's a correlation between the amount of time that a police officer approaches a vehicle and the amount of time that a bad guy is going to do something bad. Right. So you want to get up to the car as fast as possible, as I understand it. So what was happening during those 7 minutes was a little mini ETL process. It was collecting this data from different places, putting it into a little mini data warehouse, data lake, and then it was presenting that information, doing some analytics and presenting that information. We helped them with some of this technology that Dan's going to talk about, reduce that down to less than a minute, so that patrol, that officer had much more information, maybe taking a very dangerous situation and making it much safer.
Yeah. Wow. Cool.
Latency matters, you're saying.
Saving lives.
Matters.
Absolutely.
Saves lives.
So what is it really that we're talking about with this partnership? What are we delivering? So about a year ago this time, IBM actually announced taking Apache Spark from the open source and making it natively available on the platform in conjunction with a differentiator. And that differentiator is something we refer to as the optimized data layer, which is really a very intelligent piece of software from Rocket software that does all its virtualization for you on all the possible data sources on the mainframe. For those you may not know, it's not just like having MySQL out there. You got vSAM, you got logs, syslogs, you have DB2, any possible database that you might think of historically, back from the 60s, even some customers have proprietary formats, all available. You as a data scientist don't want to have any problem or access dilemmas with this. You just want to have one Python API or Spark API to access.
So it's more than SQL or NoSQL. You have your own lexicon of acronyms.
You got it.
Yeah. You make it easy.
We make it easy. We make it easy because the Rocket software is basically there for a.
I don't know a ton about it, but what I've seen looks exactly like what we were trying to accomplish with Blaze, actually, for across the internet's data.
Yes.
It was very impressive to see the engineering acumen that went into that design.
Yep.
Looks like it was pretty well done.
Thanks.
So having that groundwork or foundation served up last year, then we had a chat with Travis and Continuum, and we said, wait a second, there's a bigger opportunity here. Let's open it up, let's broaden up. This is not just Spark data processing. What about Dask? What about using the entire AnacondaCON stack? What about all the data scientists using Python? Let's expand out the framework and make it available so Python, not just Java and Scala, can run at a very economical manner on the mainframe. So at that middle layer here that you're seeing is essentially what we offer. And by the way, if you believe it or not, it's a free offering from IBM. Free on the mainframe? Huh? It's a new world, folks. So what's interesting is on the top layer is where all the vendors come in, right? So we're basically providing what you would typically find in the open source, make it available on ZOS, that's the operating system, for free for the customer. Yeah, we sell service and support for it, but then the vendors come in. Anaconda, Rocket. Oh, and by the way, even IBM will sell some Watson Analytics if you think, right? But I'll let Travis talk about the opportunity for where Enterprise, Anaconda Enterprise, and the suite there can sit on top.
Yeah, absolutely. For us, Anaconda on z/OS just opens a whole new set of hardware. Anaconda everywhere has been my mantra for the past 4 years. Anaconda on cloud, Anaconda on mainframe, Anaconda not yet on your phone, but on everywhere you have data, Anaconda wants to run. And then on top of that, of course, we have the enterprise products, some of which you've seen here. Fusion, right? That the new part of enterprise product. Right? You can bring in Excel and have the data that's coming to Excel go directly through the Anaconda stack. Yep. Now, you could configure that yourself currently. I mean, there's nothing sort of technologically different other than the ease of use. And then the whole Jupyter stack, the whole Anaconda stack, so the same workflows you're used to using, now you can choose. You can say, do I need the data center to ETL my data over to it, or do I actually need to just reserve a few LPARs? Is that the right word? That's the right acronym? A few LPARs on my z/OS in order to do some transaction processing right there. So for us, it's just an exciting way to help customers make full use of their data across the enterprise. And then that's the story from our perspective. Anaconda sits on all the data, unless you do advanced analytics on top of that, and then we bring the user stories, Fusion, narratives, and the enterprise. So that Anaconda Enterprise working on z/OS will be a product we provide.
And I want to point out that from the partnership here, the goal is that everybody in the audience that would use this, you should just view it as just another bash session that you're SSH into a virtual machine. You don't care whether that virtual machine's in the cloud, or in this case, on the mainframe. You don't have to know anything about z/OS. That's all hidden from you. That's the goal. You want to focus on your machine learning. You want to focus on your data science, okay? So if that's our benchmark for success, to make that available to you. So under the covers, what are we doing? What have we actually done? And again, I want to applaud Rocket Software here, because they've done a lot of this work. They've ported a lot of the dependencies for the underlying Anaconda distribution, the free aspects, over to the mainframe. Now, for those of you who don't know the mainframe, that's not simple. Think about it. You're talking about big Indian, little Indian, go back to school, right? Different types of architectures so that they have to deal with, and different compilers. So all the hard work, all the grunt work is being handled by this partnership. And as you can see here, we're well on our way. We still have conversations about what do we put in here, what's above the line, below the line, do we want to be free or not free? But
yeah, I think there's like 700 packages in Anaconda. There's about 10 there. We're almost there.
We're almost there. We want to get bootstrapped, right?
Bootstrapped. We'll get the most important ones first.
Yeah. So we were going to do a demo. It's kind of hard, though, in this environment, but we have an exhibit hall here where the demos are running live. And we actually have a demo that's based on a client retention a concept where you have a bank and a chief marketing officer wants to make sure she understands why they're either losing or retaining customers or clients. So if you want to see that live, please go over to our booth, and you can see a Jupyter Notebook actually running on the mainframe, hosted, by the way, by Rocket Software. I also want to point out, how would you, if you wanted to play after this session, kick the tires if you wish. It's evolving. It's not all there yet, but we want to get your participation. So Rocket has a launchpad now, but IBM is going to be hosting what's called the z/OS Community Cloud, which is essentially going to be a cloud-based access, public access, to a mainframe for you folks to kick the tires. And on that mainframe or mainframes will be this infrastructure. So we'll keep you abreast of that information. Any thoughts?
That's it. One of the thoughts I had that hadn't been touched on yet, but which impressed me when I went and saw. I know that currently a lot of the big data discussion is around security. Like there's a whole lot of folks going, okay, how are we going to make this more secure? And then when I went to Poughkeepsie and I asked a few people about security, they just kind of looked at me like, what are you talking about? We've been secure for 25 years.
It's locked down.
We've been secure for 40 years. We've been addressing that problem. They're always still concerned about it, but they've been addressing it for a long, long time. So actually I think that's why a lot of people still run a lot of their business through the IBM mainframe, is the security is sort of not a question.
What I'd like to ask you, I think it would be helpful for the audience, is when you guys go into accounts, so one part of this partnership is also leveraging the Continuum consulting, data science consulting. When Rocket or IBM go into an account and we work with our clients and we sell the infrastructure, data science knowledge is there. But I'd like to hear from you, Travis, is that when you guys go into an account today, Do you often have data access problems? I mean, because you're not on the mainframe.
Yeah, usually the biggest problem we face, most of these projects we face, I've seen people spend millions and millions of dollars on what effectively is a data engineering problem. It's just a data movement problem.
Right.
And usually it's because of multiple systems, not sharing what kind of, sometimes the format, sometimes it's more than just the hardware, it's actually what do we want to do with this data. The way it's collected isn't quite what we need to do the processing. I mean, there are still going to be needs for what's traditionally called ETL. You may need to move the data from one type of format to another, but that can all happen quickly if it's really local. So that's been most of the energy is data engineering, actually. The data science part that I really love, actually, as an applied mathematician, most of the time people are like, yeah, we got that, or sure, we'll just apply a few scikit-learn functions, but gosh, the problem is how do I get this data moving?
Right. So the message there is, if we move, using Python and Anaconda on platform, you eliminate the inhibitor of data access and focus on the real fun, right? The data science.
An example, for Travis, on that security angle, we've had customers say, I can't move this data off because maybe it's highly sensitive. And so actually they want to do more of that processing right where it lives. Don't copy it, but leave it inside this data vault, if you will. If you think of the mainframe as being this data vault, don't take the data out of there, but do your work inside there without having to copy it and get auditors or
summary
everybody
information
else.
or visualizations come out.
Which just exposes it and creates a potential leak or exposure.
I thought that was an interesting, unique thing. That made me interested and very excited about the opportunity to just, again, my view on this is I love data, and I want
lots of
the code moved to data. And wherever that can happen, I get excited.
Good deal.
So it seems like this is a perfect opportunity.
Any questions from the audience on what the partnership is and what we're trying to do? No.
I have a question.
Speak up.
Do you have any idea what that means? Like, for example, I've heard some numbers, like there's 59,000 Google searches a second.
Yeah, good point. So,
and that's one application, right? And on the mainframe, there's another application called CICS. How many?
Yeah, thank you for that question.
Can you repeat the question?
So as an example, let me repeat it. So what's the relevance of the mainframe, and is there really a lot of data there? So let's kind of analyze what we're all familiar with. You guys can all Google some of this. Every day, every second worldwide, there are approximately about 7,000 tweets per second. There are about 60,000 Google searches per second. There are also about 1.2 million Kix transactions worldwide per second. That data is being gathered by all those big enterprises. That to us.
What's a Kix transaction?
What's a Kix transaction?
Oh, a Kix transaction. Kix transaction is a type of transaction that covers, on the mainframe, your order management, your payment processing, your claims processing. It's essentially a type of transactions coming in into the mainframe. The point is, once that data is stored, you want to analyze it at point of origin, and as we've talked about amongst the partnership, wouldn't it be cool to leverage it at point of injection, right? So in real time. You can't get any faster than that, okay? So without any latency in your analytics.
Thanks. Appreciate it.